Alright class, welcome to video part 3. You know, in the interest of time, I'm not going to go ahead and talk through sample problem M. I think you can figure it out by reading it carefully yourself. Of course, feel free to come ask me questions about sample problem M if you have questions. Let's advance to the next page, page 248, and let's read together some more. It says calculation of molecular formulas. Remember that the empirical formula contains the smallest possible whole numbers that describe the atomic ratio. The molecular formula is the actual formula for the molecular compound. An empirical formula may or may not be a correct molecular formula. For example, diborane's empirical formula is BH3. Any multiple of BH3, such as B2H6, B3H9, B4H12, and so on, represents the same ratio of B atoms to H atoms. The molecular compounds ethene, C2H4, and cyclopropane, C3H6, also share an identical atomic ratio, 2 to 1. Can you see that? How there are two hydrogens for every one carbon here, and 2 hydrogens for every 1 carbon here. It's the same empirical formula, but different substance. How is the correct formula of a molecular compound found from an empirical formula? The relationship between a compound's empirical formula and its molecular formula can be written as follows. There's a little formula for you. X times the empirical formula equals the molecular formula, where the number represented by X is a whole number multiple, indicating the factor by which the subscripts, remember, are these little numbers right here, ding, 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 where the subscripts in the empirical formula must be multiplied to obtain the molecular formula. The value of X is sometimes 1. The formula masses, what's that? That's how heavy a formula, is, have a similar relationship. For example, X times the empirical formula mass equals the molecular formula mass. Okay, and that's important. It's the same formula, except instead they just add the word mass. What does mass mean? Mass means how much the formula weighs in atomic mass units. To determine the molecular formula of a compound, you must know the compound's formula mass. For example, experimentation shows the formula mass of diborane to be about 27.67 atomic mass units. The formula mass for the empirical formula BH3 is 13.84 atomic mass units. Dividing, and here's the important part, dividing the experimental formula mass by the empirical formula mass gives the value of X for dibromane. Here's what they did. If X equals the empirical formula mass, X times empirical formula mass equals molecular formula mass, they just say, hey, let's move the empirical formula mass down, and we'll get X alone, and you can find it like that. Let's keep on chugging. The molecular formula for diborane, then, is B2H6. See, 2 times the empirical formula is B2H6. Recall that a compound's molecular formula mass is numerically equal to its molar mass. One more time. So a compound's molecular formula can also be found given the compound's empirical formula and its molar mass. Okay, so basically what they're saying is, look, if hydrogen is equal to 1.007 AMU, 1 mole of hydrogen is equal to 1.007 grams. Numerically, the numbers are the same. The only thing that changes is the unit. So, let's please change the video and move on to the next page, 240. No. Sorry, let's look at our sample problem. Sample problem N. I'm going to talk you through this one. I recommend that you write it down because you'll have something like this on your quiz. In sample problem M, the empirical formula of a compound of phosphorus and oxygen was found to be P2O5. That's our empirical formula. Experimentation shows that the molar mass of this compound is 283.89 grams per mole. What is the compound's molecular formula? So you're given the molar mass, and you're given the empirical formula. let's read through. Now go to the next video, please. And yeah, get ready. Here we go.